What's up, guys? So let's solve this 576 out of boundary paths. So there are m times n grids, and they're both initialize starry column. So that you get some grids and column, and phi m max move star row star column return number of paths to move out the grid of the boundary. Okay. For example, m1 equals 2, so 2 times 2, and then your star at 0, 0, and your max move is 2. So that means after 2 move, you must go out. Right. So the idea is that after 2 move, you must go out. Okay. So this problem has a strong DP flavor. So let me one can just define DP. One just define DPI and JK to be the number of suppose you start at I, right? So you start I and J. This is your starting point, and move out. So the number to move out in K steps. Okay, so what is the recursion? Let's say I want to find the DP I, J, and K. Okay, so obviously that DP I, J, and K just, I mean, what is the possibilities that you come out with this step, right? Well, you can start from left, from here, or here to here, right? So this means that you can start from this is start from as the DPI minus 1 J and K minus 1, right? Because that means that you need to spend, you can still the number of if in this position, if you spend like a K minus 1, okay, maybe this is not good illustration. Let's see. Suppose I'm here. I want to compute this DPIJK. Okay, so that means this means that I start at IJ, and the K step I need to move out. Okay, so what is my next step? I can go here. So this means that DPI minus 1, J minus 1, and I already spent one step. Right? So K minus 1 step. And I also do this. This is DPI J plus 1, K minus 1 step. And then this is DPI, sorry, this is plus 1, minus 1, J, K minus 1 step. And also this one is DPI, J minus 1, K minus 1 step. Okay, so you got 4 choices. So DPI, J, K just the sum of all these 4. Okay, and what if you're out of, that means you only have one choice. If you're out of, then you only get 1. Okay, so the answer will just be DPI JK will be just a summation of the 4 directions, or either I minus 1 J, like a I J minus 1, I plus 1 J, I J minus 1. I plus 1 J, and I J plus 1. Okay, and if out of boundary, if out replaced by 1. Okay, that's it. Okay, so you can create your DP to be max move plus 1, because max move initialized to be 1, and for I range n, for I range m. So the matrix is m times n times number of move. Okay, so the complexity of these solutions will be O of n and p. Sorry, m and k. Okay. And so you fix k and the foreign range m and n, right? So you first, because you can see that this is the k minus 1, right? You start from k minus 1 and propagate to k, right? So you start from at the beginning, you start from everything k to be 1 or k to be 0, and then start from up to k, right? So if I 0, that means you are hit. You're in the first. Sorry, in these directions. So in this case, that you need to set to be 1. Otherwise, that you can call I minus 1, j, k minus 1. That means because you can still go left. If I equals to f minus 1, that means you are at right boundary, right? So you cannot go right. So you need to set to be 1. Or if you can go right, then you should call dpi plus 1, j, k minus 1. And if the same thing for the if j is 0, that means you are at the you cannot go up, right? So you cannot go up. So j need to otherwise that j can call minus 1 and go up. And this is a minus 1. You cannot go down. So you should call 1. Otherwise that you can call 0 plus 1. And for each dijk, you have 4 directions. So your summation of it and modular. Well, finally, just call dp star row star column minus 1. Okay, hopefully this is straightforward. See you guys next videos.